All right, let's go ahead and work on, we're gonna do 4 problems together, and then I'll let you guys practice for a decent chunk of time the rest of this packet. So the first problem says to classify triangle ABC using its sides. So you don't have to do this, but it always helps my brain, just very, very small. I make a little sketch of what this would look like, all right? So do you see the ordered pairs they gave me? I'm gonna plot -1, 2, right? This is A. B is 6, 3. And then C is at the origin. And then I just make the triangle. All right, so if it wants us to determine or classify this triangle by its sides, we are going to need to find out if any of these sides are the same length. All right, which means what formula are we going to use that you hopefully know? The distance formula, very good. So I'm going to write down distance equal the change in my x's, the change in my y's. We're going to square those differences and then add them together. Okay? I'm just going to write it once. I'm not going to write it 3 different times, even though I'm going to find 3 different lengths or distances. All right? So it doesn't matter the order in which you do this. I started with segment AB. Okay? So segment AB, I'm going to have, let's see, Sophia, if you look at segment AB, could you tell us what we want to put in our square root symbol?
6 minus -1.
Okay. And then what about for your y's?
3 minus 2.
Excellent. Make sure you're writing small. 6 minus a -1 is really 6 plus 1. So what is 6 plus 1? And then square it. 49. 3 minus 2 is 1. When you square that, you get 1. So what is the distance for segment AB? Make sure you're careful there, Brownlee. It's not 50. It's the square root of 50. All right. Now, hopefully you know how to simplify this. We're going to simplify it. All right, JC, do you know how to simplify?
25 times 2.
Excellent. So what is the square root of 25?
5.
So it's going to be 5 root 2. Now, I'll be honest with you, it's probably easiest to look at this one once we're ready to determine the actual classification for this triangle. All right, but hopefully you know how to simplify. Any questions on AB? Okay, let's do the same thing. I'm going to do BC. Carter, you want to tell us what you want to put inside the square root for BC?
You would put 0 minus 3. Oh, wait. No.
I'm going to do the x's
0 minus
first.
6.
It really doesn't matter, Carter, because you are adding.
And then 0 minus 3.
Excellent. Now those both become negatives, but what are we doing to those negatives?
Squaring them.
We're squaring them, so it will be positive. So what's -6 squared?
36.
Positive 36. -3 squared?
9.
Positive 9. So this is the square root of 45. So is that the same as the length of AB? No. Which one's longer? AB is longer, right? Square root of 50 is bigger than the square root of 45. Okay? Who knows how to simplify this?
9 times 5.
Excellent. JC knows again. 9 times 5. And what is the square root of 9? So it's going to be 3 root 5. Again, when you're comparing these, I recommend the one that has the radical before you simplify it. Okay, so we can rule out now which classification. Which one do we know it definitely can't be? No, let me rephrase. The options here are going to be equilateral, isosceles, or scalene. So which one we know is definitely not right? Equilateral. They're not all the same. All right? So now is it going to be scalene or is it going to be isosceles? All right, let's do the last one, which is AC or CA, your call. All right, let's have max M. What should we put in the square root for AC?
You can do 0 plus 1.
Okay, I'm going to write, if you're okay, minus -1, but yes, that becomes addition.
And then 0 minus 2.
Excellent. Okay, so I already heard you say it becomes addition. So that's going to be 1 squared, which is 1. Negative 2 squared is 4. And so this is the square root of 5. Can I do anything else to simplify the square root of 5? No. And if you analyze all 3 of these, are any of them the same? No. So this is a scalene triangle. So you're going to say scalene triangle because no sides are the same. Okay, any questions so far on determining the classification by side lengths? Okay, so now we're going to determine in number 2 if this same triangle, ABC, is a right triangle. So what do we know if it's got to be a right triangle? What has to be true? Very good. So now, do I know any angle measures when I look at my sketch? Do I know any angle measures? No. So there's got to be a different way then to determine if there is a 90-degree angle in this triangle. Any thoughts? Slope. Okay. More words? Because yes, it's going to involve slope.
I'm just thinking like perfect.
Slope of both line. Or like,
Oh, right. Because if they're perpendicular, what do we know about their slopes?
They're opposite.
Opposite reciprocal. And if we know that the slopes are opposite reciprocals, where they would intersect would create a
Perpendicular 90-degree angle.
exactly a 90-degree angle. So let's find the slopes of all these segments. Who remembers the slope formula?
m equals x, y2 minus y.
I would recommend doing the y on top. And when I was grading your tests, unfortunately, not all of us did that. All right, so let's find the slope of these 3 segments. I'll just do the same order if you guys are okay with that. I'll start with AB. All right, so what is my change in my y's for AB? 3 minus 2. So I'm going to put that on top. What is the change in my x's for AB?
6 plus 1.
6 minus negative 1, which is going to be addition, yes. Okay, what's 3 minus 2? 1. What's 6 plus 1? 7. So I'm going to pause here. Okay, everyone okay? All right. Again, I can't determine anything until I have 2 at least. Let's do the next one. After AB was BC. What is the change in my y's for BC? 0 minus 3. Change in my x's for BC? 0 minus 6. Okay. So that's a negative 3 over a negative 6. What does that reduce to? Positive 1/2. Very good. Okay, so far, do you see opposite reciprocals on these 2? No, I don't. So we got to do the last one. The last one was AC. Thank you. Change in my y's for AC.
0 minus 2.
0 minus 2. Change in my x's for AC. 0 minus negative 1, which is addition, yes. So that's negative 2 over 0 plus 1, which is 1, which is negative 2. Okay, so take a look at all 3 slopes. Do you see any slopes, any 2 slopes, that are opposite reciprocal slopes?
Yes.
Awesome. The last 2, BC and AC, are opposite reciprocal slopes. So what can we say about this triangle ABC? It is a right triangle. So I'm going to say segment BC is perpendicular to segment AC. So triangle ABC is a right triangle. Okay, before we move on, is there another way you could do this? Probably. The teacher's asking, so probably. Is there another way? Come on, guys, somebody can think of it. For my millions of subscribers. Come on, guys, we can do this. What's another way to determine if a triangle is a right triangle or not?
If it has like the sign on it.
Oh, yeah. Well, unfortunately, I don't have the sign on it. But yes, if it was given to you, the notation, of course, JC. Oh, man, it's like one of your favorite mathematicians. Oh, yes, Max! Sorry, I didn't mean to scare you. Yes! What is Pythagorean theorem?
A squared plus b squared equals c squared.
Awesome. So if all of these side lengths, which we already found, right? We already did the legwork. If that makes that relationship true, right? The two legs, squaring them, adding them together equal to the hypotenuse squared. If that's true, then this would be a right triangle. Let's try it. Oh my gosh. Okay, so say it again.
A squared plus b squared equals c squared.
Love it. Now, if you're going to use this one, remember, this only really makes sense if you've already done all the work to find the side lengths. Otherwise, you got to find all the side lengths to do it. Okay? Which one do we know has to go into C? Which one of these three that I highlighted, root 50, root 45, root 5, has to go into C?
50.
Why?
It's the biggest.
It's the biggest. Very good. Do I care which ones go into A or B? No, as long as root 50 goes into C. Okay? Now, when you do it, all right, write it like this, okay? So if root 5 squared plus root 45 squared. Now, technically, do I know if this is going to be true or not? No? So I want you to put a question mark right here. You see where I put a question mark instead of an equal sign? Because I don't know yet. I mean, I do. But if you're doing this before you do all the slopes, you wouldn't know. Okay? Now, do you guys remember what happens when you square something that has a square root inside? It just goes away, right? Root 5 times root 5 is just, nope, it's just 5. All right? Because you can write it like this. Max, help your brain. So root 5 times root 5. Say what you said. Say what you said. 25. So that's still inside a radical, though. So what's root 25? 5. So that's why you can just take that off. All right? So this is 5 plus, what's root 45 squared? 45. What is root 50 squared? 50. Is that a true statement? Yes. So now I'm going to write equals. Okay? And so because that works, based on what Max M told us, would this be a right triangle? Yes. What happens if this doesn't match? It's not a right triangle. And what symbol would I put here? Do you remember the not equal symbol? The slash through it. Nice, Kendall. Right? Put the slash through it. Okay? So just be careful, right? We count off points if you write things are equal when they're not actually equal. All right? Yes.
So should you only use the Pythagorean theorem on a question that's asking if it's a right triangle or not?
Yes, you can use the slopes like we did, or you can use Pythagorean theorem. Now, keep in mind, if you hadn't had to do all this work in number 1, you would have had to do all that work, right? Because you got to find the lengths to use Pythagorean theorem, right? So I think it's actually easier or quicker if you don't have the lengths to just do the slopes. But it's your call, right? It's up to you. There's more than one way to do it. Good question. All right, when you're ready, let's go to number 3. We're at 2 more, guys. 2 more together, and then it's going to be your turn to practice. All right, so number 3 says to write and solve an equation to find x. Now, it doesn't say it up there, but kind of the continuation from the last test that we did. When you write an equation, what do I also want you to write? It might include a formula, but what do I care about the most when you write an equation? That's going to be the justification. Like, why does your brain think it's okay to write this equation? That's going to help you for not just my class, but the rest of your math classes. Okay, so who has an idea for an equation that we could write? Who wants to raise their hand and try? Yes, go ahead, Max.
If a triangle adds up to 180, or no, if it is a triangle, then it adds up to 180.
Okay, now
All
I had a,
sides add up to 180.
not all sides, you're getting closer.
All angles.
Very good, right? And Max, M and I were talking about this earlier because he kept saying the same kind of thing. You got to be specific about what you're saying. So you're saying that the sum of the interior angles of a triangle add to 180 degrees. That's what you're telling me, right, Max?
Yeah.
Okay. Now, I love that you try to go with an if-then statement, right? This one, I don't need an if-then. I just want a statement for why you're saying you're doing this. Okay, so if he says that, let's see, Ruhan, if he tells me that, what equation can we actually write now?
That they all add to 180, so 7x minus 8 plus 5x plus 5, 21 equal to 180.
Excellent. I love it. Thank you, Ruhan. I think this one looks very similar to the front side of your CLT that you just did. Okay? So I would combine the like terms. What's 7x, 5x, and 6x all together? 18x. What's a negative 8 plus 5? And what's a negative 3 plus 21? 18 plus 18. Okay? Move that plus 18 over with subtraction. Very good. What's 180 minus 18? 162. Any thoughts on what x value times 18 would give you 162? What's 18 times 10? What's 18 times 10? 180. And then if you look, 162 is 18 less than 180, so it's just 1 less than 10, which is 9. Now, are we finished with this problem?
No.
Number 3. No. What else does it say to do?
Classify the angle.
Classify the triangle with using the angles. So we need to plug it in. I heard JC say plug it in. Let's plug it in. So I'm going to just plug in where it says x. I'm going to plug in 9. All right. I don't care which way, like what order you do here. What's 7 times 9? I'll do this one up top. 63. 63 minus 8? 55 degrees. So this one's 55 degrees. 6 times 9? 54. Plus 21? 54 plus 21? 54 plus 21? 75. Yes, Reese. All right. Next one. 5 times 9?
45 plus 5 is 50.
Excellent, JC. You're on fire. Now, before I go to the answer, do all 3 of those add to 180? Because that's a good check. Do they all add to 180? Okay, so always do that, just because if they don't, then something's wrong. All right. Now, we're doing this, JC, with the angle measures. So the options are, we're going to say obtuse, acute, or right. So what are we going to say? Obtuse, acute, or right?
It's acute.
We can definitely say not right. I don't see 90 degrees.
Not obtuse.
The biggest angle is 75 degrees.
Which is not over 9.
So this is going to be
Acute.
acute. So acute triangle, because the largest angle is less than 90 degrees. One more. Any questions on 3?
Oh, we have the formula.
So you actually, JC, to do number 4, you don't have to use the new formula, which we're about to. All right. I want to use it, but technically you could figure this out in 2 pieces, but we can use just one kind of direct route. All right. So I'm going to do number 4. Okay. Again, you can do this without using the thing that is new today, but I'd like to use the new one. Do you remember the new one? If you need to flip to your front page of your notes, I want to use the new theorem. Did you guys find it on the notes? Sophia, you found it? Do you see what it says? Because I'm trying to solve an equation that I write to find x. Do you remember what this is called out here? This is the exterior angle. Do you remember what the new theorem is stating today?
2 interior angles equal the exterior angle.
The 2 interior angles. And you got to make sure, guys, this is important, right? Because this angle over here is interior. But you see how this one is next to the x? Next to the exterior? So it's got to be the 2 that are not adjacent, so not next to that exterior. If you find the sum of these 2, that is the same as this angle measure. Okay? So I'm going to write that down. The measure of a...
Write this down every time we're doing
I would like to get in the habit of writing this down just to help you with like your proofs and just your reasoning skills. The measure of a triangle's exterior angle is equal to the sum of its non-adjacent interior angles.
Is this gonna be on the theorem sheet?
Ooh, good question. We are discussing that today, actually, this afternoon, of what's going to go on, what's not. So I will, TBD, I'll get back to you. Rachel's voting yes. Good to know. I'll pass that along, Rachel. All right, so now that we wrote that, Bromley, right, since you and India discovered this, what am I going to write for the equation?
74 plus 54.
Yes. You guys can't say it separately. You guys, it's together. I love it. So 74 plus 54 equals x. All right, and what is 74 and 54?
128.
Excellent. Now, we do need to do the second part, where it says to classify by the angle measures. So really, I just need your help finding what is this last angle in there. And there's two ways to do it, right? Two ways to do it. You could use the understanding we used on number 3, that the sum of all of the interior angles of a triangle add to 180, or what is happening right here?
It's a linear pair.
It's a linear pair, right? And if angles form a linear pair, then they are supplementary. Awesome. So to find that would be 180 minus 128, which is going to be 52. Okay, and again, looking at all 3 of these, I care about the largest one. What do you notice about that largest one? It's less than 90. So again, this is acute. All right.